Hey folks, welcome. In this video I will create a shader that renders a drum sequencer and it wraps it around a sphere. I will do that using ShaderBoi and then ShaderBoi to port to a Midi sequencer. So the first thing I will need to do is to create a shader in ShaderBoi. So we'll just create a new shader, and I want to have a buffer A, and an image tab. And then I will also create a common tab to contain all of my functions and uniforms. And I have to mark it as unlisted so that ShaderBoi can download it. Then I need to copy the URL, open the terminal. Once I am in the directory of ShaderBoi, where the executable of ShaderBoi is, I can just use the dl command and download the shader. Now, if I go in the extracted shader folder in the ShaderBoi folder, I will have my ShaderBoi shader saved, and I will find there the buffer A, the common tab, the image. But I also have this other file, which is a run file. This is the description of the shader, and I see how I have all of the passes here that I've created, and the passes have inputs, and I will add a buffer A input to the iChannel 0 of the image. So now if I download the shader again, and I give it a flag Y for overwrite, then if I open again my folder where my shader is contained in the extracted shader directory, I will find that the image is now a new input, and it's the buffer A that I just created in ShaderBoi. And now I want to also add a music input. That will be my MIDI input for the buffer A, where I will do the parsing and manipulation of the MIDI input. In my buffer A, I have the music input that I just added. So now let's look at the MIDI file I'm working with, because this will be important to do the parsing. I can see how the notes that I'm using in this drum patterns are from 36 to 43. So I can define the range of the notes that I'm using using a constant integer vector 2. And then I can also define a uniform as my Midi texture for iChannel 0 for my buffer A, just to make it clear. Now I can go ahead and create a function to extract the note velocity. And to do that, I need to have my Midi texture as an input, and to know which channel I'm working with and the pitch that I want to extract. And then I can have an in-out boolean, which will tell me whether the note is on and off, or on or off once I'm done calling the function. So I can subtract 1 to the channel just because I want the channels to be indexed from 0 when I parse through the texture. And then I want to create the texel coordinates so that I can target the pixel in the Midi texture correctly. I want to have a uniform that tells me how many rows per channel I have, and that will be 5. And then if I multiply that 5 for the channel, I will target the right block of pixels. I want to have a way of recognizing the node on and node off. And for that, I can just use the seconds since node on and seconds since node off as an indicator. And so I need to extract those information from the Midi texture as well. I can just update the boolean on by checking whether the seconds since node on are less than seconds since node off. If the node is on, I can return the velocity. If the node is off, I will just return a 0. So here I skipped ahead a little bit. You can see how I have created an ID for my node. And then I want to gather the pixel from the previous frame. And to do that, I will just get the feedback texture. And I will set the default of the on boolean to false. Then I will get the pitch by adding my ID to the bottom of the node range. And finally, I will extract the velocity. And now I can go ahead and create a trigger boolean. And the trigger will be true when on is true, but also when was on is false. And was on is a float, so I can just measure whether that's less than 0.5. So let's talk about the sector. The sector will describe where in the grid my node is, where in the time grid my node is. So I need to create a time unit, and in this case I want to I created a 0.1 time unit, which is 100 milliseconds, which happens to be consistent with the tempo of my pattern, which is 400 milliseconds per beat, and therefore the BPM will be 150 in my pattern. So this is of course dependent on the MIDI file, on the MIDI track you're working with. My time unit needs to be multiplied by my bit width, which might change depending on your pattern. In this case, my bit width is 4. The time section in which the note falls is given by the modulo of I time bit width times the time unit divided by the time unit, and I want to get the floor of that. Now I know in which of the 4 slices of the texture the note will fall. And then I can have a decaying envelope. So the slide function gives me an interpolation between the current value and a target value over time. And in this case, my target value, once the envelope starts decaying, is 0, while my current value is the envelope itself. Now I have my pixels that are being set according to what I just coded. And let's just look at the envelope right now, and you can see how the notes are being set by my MIDI input, and my duration is dependent on this value that I gave. If I divide 1 by a higher value, then I will have a longer decay, shorter value, shorter decay, etc. And now I can go ahead and translate that into coordinates for the texture. So to do that, I need to change my conditionals. At the beginning, I will have the first row that is dedicated to parsing of the notes, and it will be on row 0 and on a range that is equal to the range of the notes that I have. And then I will set the coordinates of the texture using the second row of the texture, and then the rest will be just used to render the rest of the texture. So here I skipped ahead a little bit. So here I'm just creating the coordinates for the texture, and I create a width and a height of the texture to slice it into rectangles pretty much. And the width will be the bit width, so I can then divide it horizontally based on the bit width. And the height will be determined by how many nodes I am parsing. Multiply the horizontal width by the time sector, and I will multiply the height by the ID of the node. So moving on, now to render the whole texture, my ID of the texture will be the UV of the texture, the UVY of the texture, that goes from 0 to 1 on the vertical dimension by how many nodes I have. And that will give me, if I take the floor of that, will give me the ID of the node that I need to use in that particular horizontal dimension. So the center sector will be parsed from the second row of the texture, and I will only need plane X and Y. While for the data itself, I want to use both the envelope, which is on plane X, and the sector. I need the sector which is on the Z plane, the Z channel of the texture. So the pixel sector will be the UVX multiplied by the bit width. And if the pixel sector is equal to my current sector, then I want the envelope value to be displayed. Otherwise, I will have 0. So I didn't create the UV, the normalized UV yet, so I will just do that now. And then I want to also, there is a mistake here, I need to have vector 3. And this is the texture as is output from as a simple texture on the screen. So now I can go ahead and create a sphere. I want to create my rays, my ray origin, my ray direction based on the camera function that I just pasted, and then have a render function that will display this texture wrapped around a sphere. So to do the wrapping around the sphere, I don't need to do any ray marching. I can just use an analytical sphere distance that was provided to me by ShaderBoi user NR4, whom I thank again. It's a useful function that returns a distance to the entry point and the exit point in a sphere given a ray origin and ray direction. So I can call the output drums and give it a default value of 0. Then I want to create a drum sphere, which is my function a sphere with a radius of 2. And then if the drum sphere X is less than a large value and the drum sphere Y is less than a larger value because it's on the other side of the sphere, then I can calculate a point in the front, which is my ray origin plus the ray direction times the distance. And then the sphere UV will be given by my point using the polar coordinate. In the polar function that I created, the theta and the phi values are normalized so that I can use them as UVs for texture lookup. If you like this video, subscribe and like the video. I usually post videos of different nature, but I try to post videos about audiovisuals as often as I can. Feel free to subscribe and check out my Patreon page. And until the next time, take care.